Hello, Internet. This is Sean McBride with Kait Moreno.
Hello, everyone.
And today we're going to start the first in a series of hopefully a bunch of video posts on the Rust programming language. We're
Oh,
both,
you got the hard copy.
so I didn't.
Oh,
Our esteemed, your coworker, my former coworker, Douglas Fort, gave me this
really?
as a going away present.
Wow, such a sweet guy.
He's such a great guy. So Kate and I are just really excited to learn the Rust programming language. We worked together at Decipher. I left to go back to grad school recently, and I've been doing a lot of C++ programming in the meantime. But like I have a little bit of a hole in my heart for JavaScript and NPM because I just don't get to do that as much now. And so it's kind of like to me, I feel like Rust is it's like the sweet spot of you've got like something that's kind of like NPM, you've got a lot of the niceties and tools, but you also have some of the low level stuff like C. So
hmm
yeah,
Yeah, I felt right at home with cargo. It was
with
nice.
Cargo, yeah.
Yeah.
So like to me, I think Cargo is maybe like the number one reason I was attracted to Rust. Like so at Decipher, like I did a little bit of Golang stuff.
hmm
And Go, I mean, they're starting to talk about adding a package manager, but they haven't had anything like that until super recently.
Well, there's Go modules now, right?
I Yeah, you might know more than me. It's
Yeah,
been a little
and I
bit.
know that it is divisive, but that's uh,
Yeah.
all I know, and very recent, like within the past few weeks, I think. So.
Okay. Well, cool. Good for them. Good for them. But yeah, Cargo. Like you could basically do like a Cargo project generator. And
hmm
one of the things I thought was really cool about that is it even does like the initialization of a Git repository,
Yep.
which is like,
It
hey, that makes a lot of sense.
Right. It's like kind of enforcing some best practices there.
Yeah,
And you don't have to, have install like a create React app like package to start a project. It's all built in, which is
yeah,
cool.
totally. So I
Um,
guess I've got like a list of some topics. Do you want to just kind of go through it, Kate?
sure.
So I guess like the first, let's talk a little bit about our goals for learning Rust. I mean, going through this whole book is going to take a good chunk of time. So why do we want to do it?
Well, for me, I would like to kind of dip my toes into some, I guess stronger typed languages than JavaScript and just start. I mean, I started with learning programming with a little bit of C, but quickly moved on to JavaScript. So I just kind of want to, I guess, broaden my horizon there a bit. And
Cool.
second reason, which we talked about, is possibly contributing to the kind of reboot of Node, which would be a cool goal to accomplish.
Yeah.
Deno,
Yeah.
which is Ryan Dahl's reboot of Node written in Rust. So
And
yeah,
TypeScript.
and TypeScript, yes. But
Yeah,
we've already dipped our toes into that.
yeah,
But,
we have. Yeah, we pair programmed on a Node microservice. Lots of fun. Yeah, so I think I've got a lot of similar reasons for Rust. I mean, one other that I would add is kind of the WebAssembly story. So like Mozilla is the big force behind WebAssembly, and because Mozilla is also behind Rust, it seems like Rust is like the number one programming language for having like really fast running compute intensive stuff. And I mean, there are a lot of languages that are kind of looking at WebAssembly, like C# is this Blazor thing, and then Go has this other thing, and Python is this Pyode idea. And it's like what all those languages are doing is they're taking like the whole kind of language runtime and they're compiling it into this ginormous WebAssembly thing. And so then it's like whenever you load up a web page, you have to pull down like, I don't know, 2, 3, 4 MB of like language runtime. I think for the Python one, it's huge. It's like 20 MB or something like that.
Well,
And then you just get to build a web app in like Python or whatever and do similar stuff with JavaScript. So I feel like some of that stuff is a little bit silly to me because it's like, who wants to pull down 20 megabytes of runtime stuff? Like JavaScript is pretty good. I'm happy with it. But like Rust, you can produce these little pieces for the little bit of code that doesn't run super fast in JavaScript. And so
right.
it's like kind of fit for purpose, pick the right language type stuff. Yeah.
Yeah. Cool.
Yeah. So we kind of talked a little bit about it, but what were your general impressions of Rust?
Well, like we talked about, it so far, just the first few chapters, I feel pretty at home. I was a little nervous starting, like, what am I going to get into? Like, is this way over my head? But I found like most things had some sort of comparison in JavaScript, whether that's like the package manager, kind of, yeah, like dependencies, kind of these built-in functions, the language. Yeah, like, so they have this kind of match function, I guess not a function, but what would you call it? Like language feature, I guess, that was really similar to like a JavaScript, like switch statement or a bunch of chaining if else blocks. So that looked familiar to me.
Yeah.
Um,
Yeah, that one was kind of interesting to me too. Like, so one of the things you can't do with a switch statement is you can't use it as like an expression, and you have like a let result equals switch something or other. Like you have to kind of define a variable and then mutate that later on.
right. So like you switch on a variable.
Yeah, right.
Right.
You can actually use that Rust match thing as like an expression, and it just seemed very kind of functional and nice.
Right, where we kind of reassigned that guess variable to the match statement result.
Yeah, totally.
It's cool. Yeah. What else? I liked how they call all the import statements at the top of the file the prelude. Thought that was very poetic.
Nice. That is poetic. but you're a pretty poetic person, Kate, but you don't like the idea of being called a rustation?
I don't know. I'm still on the fence about that. A little. I don't know. I feel like they needed to present that later in the book. I need to warm up to that, the language first.
Yeah, I feel like the Rust branding is a little confusing because it's like they also have that like big cog thing with the R in it.
Right, and then I was trying to figure out. So they call when they were introducing cargo and talking about the package managing. They were saying that like a package of Rust code is called a crate, and I was like, well, where does that fit in the analogy there? Like
crates of crabs.
Yeah, crates of I guess rusty crabs.
Rusty crabs. Well, I guess rustaceans are like pointy and hard on the outside, but soft on the inside, or something. I don't know.
Okay, well, it's a stretch, but
it's a stretch. Yeah, we'll see. We'll see. Yeah. So you mentioned you did some C programming, and so C is like a ahead of time compilation type language.
Yes. So the having to kind of compile your package before you run it is at least familiar.
Yeah.
So wasn't too like traumatized coming from JavaScript.
Yeah. I mean, what do you think are like the major trade-offs of like ahead of time versus just in time compilation? Any thoughts on that?
I mean, well, they point out in the book, like dev experience, like, right, you have this extra step, right? But then, of course, the bonus is you're catching code before it's running, right? You're not compiling at runtime. So it's a safer approach, I guess, but it's, I guess there's probably, I haven't looked into it, but there's probably some tooling around that for the developer experience problem, I would guess, like.
For the Rust compiler?
Yeah, for the Rust compiler.
Yeah, so you were using VS Code, right?
Yeah.
Did you have all the extensions and stuff installed?
I did, yeah. One of the first thing I did was like install the cargo formatter too.
Uh-huh.
Yeah.
Yeah,
Things like that. But
it seemed like all the feedback and like IntelliSense type stuff like worked really great.
yeah, that's nice.
Yeah, so I'm trying to think.
How do you feel about the trade-offs there?
Yeah, so I mean, like ahead of time compilation, you end up with this little binary, and you can kind of ship that out and share it, and you don't need to have like a JavaScript runtime installed or like Node.js or anything. So that's pretty cool. I guess a trade-off is like, so like that V8 runtime, it's pretty fast. Like, and it has this thing called turbofan. I think, is that right? I think that's the just-in-time compiler. But like the cool thing it does is it's constantly like looking at how JavaScript is running and trying to find areas that like it can optimize, and then it basically recompiles that stuff continuously as the program runs. So it's like to some degree, the just-in-time compiler has it knows how the program is actually running, so it might actually be a little bit faster in some situations. But I don't know. I feel like yeah. So for school, like I was doing some profiling for WebAssembly versus JavaScript, and like the big surprise for a lot of things was, whoa, JavaScript is actually incredibly fast. Like it has a reputation of being kind of slow, but it really isn't. It's pretty quick.
Does it have that reputation? I haven't heard that really.
Well, I mean, a lot of the computer science people are bashing on it anyway.
I'm not in this elite crowd.
Well, yeah, so I guess that's the cool thing about Rust is that it's like approachable. It doesn't necessarily assume all the computer science stuff, I would think.
Right.
Yeah, but let's see a couple other things. So I thought it was an interesting choice that variables in Rust are immutable by default.
Yeah, for sure. And the syntax around it is a lot, I guess. Yeah, I thought it was interesting that you also had to kind of access variables in that way. Like you, I think that was the case, right? Like when you access when you access a variable, you have to specify that it was a mutable variable that you're accessing.
Oh, I forgot that. So you got to do it every time you reference it.
Right. I thought that was interesting. So they really,
they're really discouraging.
Yeah, exactly. They're like, you're gonna have to type more if you want to do this.
Yeah. Huh. Yeah. That's pretty. I feel like that's like right on trend for programming styles right now and functional programming.
Yeah. In what way?
Just I guess how immutability, like everyone is kind of like, you should really be using immutability. Object-oriented programming it really emphasizes like bundle of state and constantly changing it, and that's got all these downsides. Like I don't know if I necessarily buy into that worldview totally.
Yeah.
But I don't know. I hear it a lot.
Gotcha.
So like there were a couple other interesting things about the variables. Like I noticed in the chapter they mentioned this idea of shadowing.
Yeah, I was gonna bring that up too. Yeah. It's
you want to describe what that is?
So shadowing is I guess it would be a way to like replace the value in a variable. So in this Rust chapter, or in this chapter of the book, we built a guessing game. And so we stored the user input, the user's guess in a guess variable. We initiated that as a new string. And then later, we wanted to compare that guess against the secret value that they were trying to guess. But the secret value was a number. So we needed a way to like convert that the user's input, which was a string, into a number. And so the way that they approached that was through shadowing.
Mhm.
So we basically it seemed to me like basically reassigning the variable. I'm not sure what other like mechanics were going on behind the scene there. Am I missing something?
No, I think that's pretty much right. I mean, the only thing I'm not really sure is if it's really reassigning or if it's doing something different where the previous value still exists. Because it's like if it's reassigning, then there's like a reference in memory, and we're like
Yeah,
updating that little chunk of memory. Like
right.
I kind of had the impression that maybe something else is going on. So I don't know. Maybe we'll have to learn in a future chapter.
So you don't think it's actually just moving the pointer to a different, like moving that variable's pointer to a different memory location. It's actually like creating a new variable that shadows the first variable.
Yeah, because it's like when I have heard that term shadowing before, usually it's in the context of like blocks of scope. And then like the more local block of scope, you declare the variable using the same
Right,
name.
right.
And the outer variable still exists. It's just that the one on the inner scope is more local, so it like intercepts it. So
I see.
yeah,
Yeah, that makes sense actually. So it's right. Yeah, you're right. I don't think it's reassigning then. That, but I guess the way that I guess from a JavaScript perspective, like looking
yeah,
at that code, that's the way it looks. Like
uh-huh.
we're defining, and I guess that is the way I'm used to seeing it in JavaScript with these different blocks. And the way we did it um, in this example, they were just, it was like the next line basically. And
Yeah,
it looked the same as a reassignment to me. Um,
yeah,
but I guess that's the language difference then.
yeah. Well, we'll see. We'll learn more, I'm sure. And then I guess the other interesting thing about the variables is kind of the typing to me.
Yeah.
Um, so, I mean, we both used a couple of languages, and it's
Mm-hmm.
like some languages you have to basically define your type up front. You don't have like a
Mm-hmm.
let keyword. You've got like the type is kind of the
Right.
keyword.
Yep.
And so you got to do that up front and you got to like manually define that.
Mm-hmm.
The type system for Rust to me felt a lot more like a TypeScript type thing where it's like it's optional in the sense that like it'll infer types and then kind of yell at you if you do crazy things, I guess. But
Oh, so I didn't realize that it would infer types,
yeah,
actually.
I think if you remove that like colon type annotation thing, it should still all work
Oh,
because
okay.
based on like what you're assigning.
Interesting. I think we should try that.
Yeah,
I want to like see that fail or yeah, what that looks like.
they'll be like, haha, you're wrong.
Yeah.
Yeah, we'll see. Yeah, that's yeah. And then I mean there are just some other differences. We talked about cargo and npm. Like it seems pretty analogous and similar to me.
Yeah. So what is the like equivalent of like the node modules kind of thing? Um, is that do you know how that works in Rust?
Of a node modules thing. You
Like
mean like where it's
it,
stored?
yeah, is it just pulling the resource? Like is it storing that somewhere?
Yeah, so like the npm equivalent basically. I think that's something a website called crates.io.
Right,
Um,
I saw that, but I guess uh, where is it throwing that in the
oh,
project is my
yeah,
question.
I do think that's different. I think that might actually be in our user directories in a hidden folder.
Ah, okay,
We
gotcha.
should check that out too. Do a
Yeah,
look at the hidden. Yeah.
right. And the other thing about that in the book, they were talking about how there's a difference between binary crates and then library crates.
Hmm.
They make that distinction, but didn't really go into it much. So I wasn't sure about that. They just say like library crates are intended to be used in other projects, but I don't know.
Yeah.
Yeah,
I
like
guess that would
they're
be like,
built differently, or
yeah, I'm thinking like, I mean, I guess the library crate is kind of like an NPM module kind of thing. And then
sure.
what's that? Is it NPX? What's the thing where you can like
Yeah,
just, yeah,
NPX, my fave.
and that might be more like that binary thing.
Okay,
Um,
gotcha.
so at this point, Kate and I had a really productive pair programming session. Unfortunately, the recording seems to only have captured my half the conversation. So to spare you the pain of listening to me basically talking to nobody in particular, I'm going to go ahead and try to summarize the pair programming session and the content of basically what we discussed. So this is Kate's guessing game program. And we'll step through basically line by line how it works. But first I want to show exactly what the program looks like when run on the terminal. Kate's using cargo run, and that basically compiles the program and then immediately executes the binary. And the user's presented with guess the number, please input your guess. And then at the console, you can just input numbers. And based on how that number compares to the random number that the program generated, you're either told too small or you're told too large. And that's using a random number generator crate and a enumeration for comparing numbers from the standard library. It takes Kate a little bit of time to come up with the actual number. She's getting close here, but once you finally got it, it says you win, and the program goes and exits out. So let's go ahead and step through the logic here. So we're using this external crate random since the Rust standard library does not provide a random number generator in the core standard library. We're using the ordering less than, greater than, or equal to enumeration from the standard library, and we're using standard IO, which I believe is providing us access to this print line macro. At the Rust programming language book specifically called out that this Rust or this print line exclamation point is a macro and not a function. So I don't particularly understand the nuances of that at this point, but we're going to probably learn a little bit later in the book, and we'll share once we've figured that out. The program then uses this function thread random number generator to create a generator using a default seed, which is provided by the operating system. And then we use that random number generator to generate a range between 1 and 101 exclusive. So between 1 and 100. Then we enter this loop. We're using basically a very simple loop construct here, which is the loop keyword with a block. And inside of that block, we use the continue and break keywords to control how that loop executes. But from the point of view of the syntax, it just executes infinitely. I'm sure there's more complex looping structures in Rust. We just haven't encountered it yet. Each time the loop runs, the user is prompted for a guess, and we declare a empty string, and then we use the standard in to basically read the line. So the user types in a number and they hit the carriage return, and that gets captured here. We're passing a reference, which is kind of equivalent to a C pointer, and notice that we are saying that it's a mutable pointer, and so this read line goes ahead and it mutates the memory that this reference is pointing to. And then down here we have an error condition basically. So if this read line is returning either an OK condition or an error, and in the case of an error, this string that we pass into expect gets printed out to the console. Actually, I thought it was kind of weird that this is called expect. Like I would think this would be like a catch or something like that, because expect sounds like you'd expect this to run or something like And this is kind of like we're catching unexpected conditions. So once we have that input captured in the guess, it's the form of a string. And we have to go ahead and trim any spaces at the beginning or end, and that includes kind of the carriage return control character, and then parse it into a numeric value. Since this is just parse and not like a parse int, parse float or something like that, I presume that this gets coerced based on this type. We're using a match statement here to basically you've got two arms in here. Depending on if this expression returns an OK, we basically pass a num, and that gets set to this guess integer. If there's an error, we call continue, which takes us all the way back to the start of the loop up here. So then the user gets immediately reprompted to enter a value. So at that point, we tell the user what they guessed, and we compare against the random number. This match down here has three arms, less, greater, or equal, and we either provide hints to the user that they need to increase or decrease their guess, or we tell them you've won, and then we call break to exit out of the infinite loop block and exit the program. So pretty basic guessing game. We wanted to enhance this though, to be able to basically prompt or tell the users how many guesses it took them to basically come up with a random number. And so to be able to do that, we created a new variable called number of guesses, and we initialized it to 0. But once we did that, we were kind of curious what would actually happen if we did not go ahead and initialize this with a value. And we tried to print out a uninitialized variable in Rust. And our hope was that the compiler would protect us. So we went ahead and did that. And it's kind of hard to see, but we got some compiler errors down there, which were very helpful. So we went ahead and fixed it and reran, and things compiled and worked okay. At this point, we basically spent a little bit of time guessing the syntax for incrementing a integer. Turns out that this plus plus syntax is not offered by Rust, but this plus equal syntax seems to work. We were kind of surprised that we were able to do this because we were under the impression that we had to have this mutability keyword here to be able to change a value, but it seemed like we were able to just do that here without putting a mute in front. So our best guess was basically that this plus equals is always mutating something, so it's probably implicitly providing that behind the scenes, or maybe it isn't as required as we initially thought. We print out here the number of guesses and run the program, and that works fine. But instead of just basically printing out the number of guesses each time and incrementing that, we thought it'd be a little bit more useful to have a set number of guesses, and if the user runs out of guesses, just go ahead and exit out of the loop early and present a you lose prompt. So we go ahead and define a new variable called max guesses, which is equal to 7. And we have an expression here to calculate the number of guesses remaining. And you can see we've got 7 there. And this actually runs and works. And the reason it works is that we actually exit out of the program with an error condition because we basically overflow the number. And that's because if you look back up here, we're defining the number of guesses as an unsigned 32-bit integer, which is able to store, I think it's like 0 to 4 billion or something like that. And so if we try to decrement from 0 to -1, we have an error for that particular data type. So obviously we want to fix that. So in order to fix that, we want to add a new check to make sure that the loop exits if the user runs out of guesses. And we decided to add that here at the top of the loop. And then at that point, the program works properly without having any sort of data type errors or anything like that. So finally, we wanted to clean up the code. One thing we thought about was how I mentioned this unsigned 32-bit integer can store pretty large integers. Probably the user isn't going to guess a million guesses here. There's only like 100 possible numbers. So we could shrink that down, and we went ahead and changed that to an unsigned 8-bit integer, and that worked okay. And then we had the thought that down here in these loops, we have kind of repeated code. So wouldn't it be nice to be able to dry that up? But we weren't totally sure syntax-wise how to write new functions in Rust yet. So we tried a couple of different things. We saw this. There we go. We saw what kind of looked like ES6 JavaScript syntax, like kind of fat arrow functions. And so we tried that here, but that syntax didn't work. Maybe that's a special construct that's only used for the match block. We're not totally sure. The compiler did give us some pretty helpful warnings, though. Yeah, that's right. So this would run, but we got an error about scope because I guess this is like a Lambda function, and it doesn't basically have access to dynamic stuff on the outside, on the outer scope. And the compiler suggested use a different construct called a closure. And so we used the compiler. It presented a particular error code, and when you type that in, it provided basically the equivalent of like a man page that showed the syntax for what the closure syntax would look like. And that's basically from the man page there. But when we refactored to that, we still had some errors. So at this point, we just kind of thought, well, we'll learn this in chapter 3 and come back to it later. So that's everything from the pair programming session. Hope you found this interesting. Kate and I are planning on covering the next 2 chapters and have another video hopefully in a week or so. If you have any tips or feedback or suggestions about tools so I can actually record a pair programming session and have both sides of the audio, feel free to make suggestions or leave any comments or feedback below. Thank you very much and have a great day.